here, that is 0.08. After reaching here, this is a chamfering operation. Okay, see, means here we are writing the program like this, but machining action may be different. It is not like that it will just enter from this side and it will just cut like this. We are just providing it to the points and it will move like this only. Okay, it will move like this only, and it the main reason of providing this scan cycle that it will automatically calculate the end, means the intermediate points. Okay, so I think this will be not creating confusion. This is similar thing, means if it here we are just writing that if my tool will move from this point to this point and to this point, how can we write? It is simply a linear interpolation to that point. Okay, now you see, suppose these two lines, um, the same linear interpolation is there, that means I may skip this G1, and in between these two lines, if there is no change in X, I may also write, I may also skip this X14. Okay, so I think up to this it may be clear that N1100, but this is the end of your roughing cycle, but that means my final dimensions is not achieved. It will still leave certain values in X direction and Z direction. Okay, now after completion of this, again my tool will move to a safer location X250 with this rapid rate, and I am writing G0, G42, X200. If you remember what I told about G42, it is something related to the tool
nose radius.
radius.
Yes.
Okay, so that may be different for different tool. If that value will be not
What does that mean?
okay, let me okay.
What does mean by the tool nose radius?
See, we basically assume that this is a sharp edge, but in practically when you will see the tool, it will have some rounding. Okay, so this
Yes,
rounding or this tool nose radius, it may be also different for different tool. Let's say there are two tools, their tool nose radius may be different, and if we will not take this tool nose radius into account, there may be some deviation in the final dimensions. Okay, so basically in roughing operation we are not taking this into account because this is not my final value. So after roughing operation I must take this tool nose radius. Okay, and it will do certain modification in the tool path so that the final dimensions after finishing operation it should be same as the desired. Is it clear?
yes, sir. Yes, sir.
Okay, now coming to this provision is done. Now we have to go for the finishing operation. So G70 is finishing. G70 is the code, G code for finishing operation. Again, so it will finish. It will, now we'll go for finishing. But what are the coordinates? Again, it has to reach P1000 Q. This is also a CAN cycle. Again, we are writing P1000 Q 1100. When we write this, the control will again search this N1000 and it will repeat this operation. But what is the change between what is the difference between this line and this line? Now you can see after this there is no allowance left. Okay, this is my final dimension. Okay, so there is no U and W over here. And any modification that we are doing, yes, we are modifying the feed from a higher value to a lower value. Okay, so that my final surface finish will be better. Okay, now
Sir,
yes,
sir, what is the P and Q is here, sir?
P and Q are the starting and ending.
Range P.
P is the starting. P is the starting line. Q is the starting line. Means it don't denote
Sir,
when
that is the
What is
N
thousand and
N1000.
thousand and hundred?
see
Yes, sir.
So if
Let's
P
explain.
and
N1000
Q
and
denote the
N1100
me,
is the
sir.
starting
See.
value.
P means this is the starting line number. So P1000 means the starting line number will be N1000 and Q means this is the ending line number. So that means there must be N1100 and in between I must write all the coordinates and the path. Is
Sir,
it clear?
N1000 and P1000 is same.
No. Whenever I write the P1000 means there must be a N1000 and my control will go to this location. This
Sir,
is
I
so
just
this
the
didn't
P
format.
understand.
and Q is for CAN cycle.
Yes. This is for the CAN cycle. Okay. P means this is the starting line number. Okay. P1000 means there must be my control has to move to this N1000. See here also we have written P1000
Sir,
Q.
N1000 is also a starting line number.
No, this is the sequence. See, N means this is the sequence number. Okay, means a sequence a line number, but what I can tell. My
Sir,
Excuse
yes,
me, sir. Sir, why is N1000 not on the right side?
N
sir, I
1000.
think P100 tells to go the code to N1000 and the code between 1000 to 1100 is executed when P is just for calling the block.
Yes, you're right. Okay,
Sir,
now
that means
Sir,
if
then
I
why is
write
N1000
P800,
and
then you have to
N1100
write
not here?
N800.
sorry.
Why is N1000 and N1100 not on the right side of the code? On the right side.
Okay, means this is just the format. You are telling that why U and W should be like this and P and Q. It is
No, sir. I'm asking why is N1000 not on the right side, but it is on the left side. It is necessary, for starting the loop operation. I mean,
yes,
canning cycle.
yes.
Sir, I didn't understand P1000 and Q1000.
There is this is
Hello.
just mute your thing because the voice is coming. See, this is just the format. See, this is just the format. We can't write. Suppose we know that G01 means this is a straight line we have to move. Okay, and instead we can write that this is. Suppose we don't know anything, we have to move the tool like this in this manner. So what I need to do? At this point, I must write this is a linear path. So this is G01 and this point I must write. Then after reaching here, again I have to reach this point and this process will continue. Okay, but in that manner, it will take a lot of time. So instead of that, what we can do, if we can write in some CAN cycle, which is a repetitive cycle, and we will just provide it the end points and the path means from point 1 to point 2 how it should move. So it will automatically calculate the end points. Okay, so for that we need few things that we must specify what is the depth of cut and what is the point that has to be reached and what is the path. If it is a straight line or a circular interpolation, that thing we have to give. So how can we give in a CAN cycle? This is the first line. Okay. So whenever it finds that G71, that means this is the CAN cycle. It enters and it sees that we need to go to P1000 means it need to go, the control must go to N1000 and it should execute up to this N1100 reached. Okay, still after this machining, there must be some finishing alliance. This is given by U and W. U and W means finishing alliance in X and Z direction. Okay, so F is the feed. Okay,
Sir, so
so
it is necessary, to write N1000 and 1100. Then why it is not written on the right side?
I am not understanding. Means uh, this is supposed to be written in the left side. Even if we may skip this all thing to the under that means N1000, then is on the next line we may start from G0 X12. Okay, so it cannot be. I think it can't be written on the right side. Okay.
Sir, if we are simply skipping
So
because
this code is
we
defined
can
only
write in
once for
P1.
the entire code.
Yes.
So this code must be defined only once for the entire code.
Yes, yes. See, on this
Okay,
finishing
sir.
cycle, we are not defining the coordinates again. Again, when we are writing, again it is the control will go to this line and it execute all the dimensions up to n1100.
Yes, sir. Yes, sir. I understood.
Okay, let me proceed. Otherwise, you will be late for the other things. Okay. Now, once the job is done, we have to go for the parting operation. That means we are not means there will be a tool change and it will come and it will just simply cut this. Okay, so this will be a new part. Okay, so for that, what we need to do, we must change the tool. And someone asked what is G28. G28, I told that this is just zero return. Means the tool changing cannot be done from any location. First of all, uh, the tool that is being used that must be shifted to a, suppose my tool is means it is used here, this must be returned to certain safe location where the tool changing can be done. Okay, so by writing G38U0, it will tool, the present tool will move to in that safe location in X direction, and G28W0 means this will move to the Z direction. Okay, now it reaches a safer location where the tool changing can be done. So before that, G50 we are establishing that the maximum speed this speed will be 2000. Okay, now by changing the tool, how we can write that this is the T0707. Okay, that means we are changing the tool from 6 to tool 7. Now S80 means this G96 S80 means this is the
Sir,
cutting
what is
speed.
AM42, sir?
M42.
Yes, sir.
The M42. Let's see again. That is M42. This is spindle speed high. That means we are operating at a spindle speed more than 1000 RPM. Okay. Spindle speed low means the RPM is less than 1000. M42 means spindle speed higher than 1000 RPM. Now, now what is that? G0 X32. Okay, that means uh, the tool will come to this point rapidly because there is no machining action. Then G0 Z minus 63 minus, sorry, when we write X32 means it will come to this location. Okay, and minus 63 means directly it will come to the location, this location. Now from this location my tool has to move up to the center, and so it will be G1 and this will be a machining action. So this will be G1 X minus 1.0 and at a feed of F.2 because our objective is to cut this entire workpiece. Okay, at this point it must cut it. So what we can do? We can move the tool from this point to somewhere to the center. Okay, so that it will be a different part. So this is the code for that. Okay, I think we
So,
can understand this. Okay.
sir, what is the G1 is here, sir?
G1 is the linear interpolation.
Sir, that is G01.
Same. Sometimes we can write G01 or G1 also.
Both are
Okay.
same, sir.
Yes, yes.
Okay,
Okay.
sir.
So now this is over. Now we are going for the machining center, or it is similar to your milling operation. See here, there will be a G40, G41, 42, but here it is a G40 is not the nose radius, it is the cutter radius, because in milling or machining center we are dealing with end milling cutter. Okay, now see, this is the program, this is the part drawing. Okay, now what we need to do, first of all we have to, and this is my origin or 0 0, and this is the dimensions given. My first job is to calculate what is the coordinate of these points. Okay. Now, if this is 0, 0 and this dimension is 20, 20, so this coordinate of this point will be 20, 20. And similarly, we can calculate this dimension was not given in the diagram. Okay, but this is there. So the coordinate of the all these points means we can calculate from these dimensions. Okay. Now, see, I want my tool to move from this point to this point. Okay. So in that case, don't you think that if because here the tool will have some height and the diameter. Okay. And we always write the code for the center of the tool. Okay. And if the tool will move from this point to this point, some extra material will be, see, if this tool will move like this, don't you think that this extra material will be cut? It will deviate the the desired dimension. It will desired dimensions will not be met. So what we can do, we may move this tool to the right of this line so that my next tool position will be somewhere here. Means it will be like the shifting of the tool from this point to this point. Okay. Now, if I will try to move to the next location, it will move in such a manner that this profile will be met. Is it clear? Is it clear?
No, sir. No, sir. Can you explain once again?
See, my job is that my tool must move from this point to this point. If that is to be done, then that means this much of material will be cut. Basically, see, okay, some of the things I think I have missed. For machining center, your Z movements are done by the movement of the tool up and down, and X and Y movements will be done by moving the bed. So basically, see, no, okay. So if this is the bed and there will be some job mount on this, okay, and on this we will do some operations. Okay, I think it is not there. Okay, how can I take? Okay. Suppose this is my cutter, okay, and I want to move from this point to this point. So in that case, the dimensions means it seems that it will move in this path, but it will cut some extra material. Depending upon its diameter, it will cut some extra material. Okay. Now, to avoid that, what we need to do? We have to move the tool to the bottom. Okay, we can shift the tool to the bottom, and I can move in from this point to this point in such a manner that this profile is made, or this okay.
Yes, sir. Yes, sir. I am.
Okay. So how can we do that? Means shifting of this tool. So here we are shifting the tool from means to the, you can see here it is written G41 is the cutter radius compensation left of side. See, this is the, in this direction we have to move, and we are moving the tool to the left side or right side of this line. We are moving the tool to the right side of this line. So we must write G42. Okay. Suppose the same part can be cut by not moving in this direction. Suppose I want to move in this direction. So in that case, my tool has to shift to the left of this line. So in that case, I have to write G41. Is it clear? Okay. Now, See, just here we have some new codes. I have just encircled those things. See, there here there will be three axes: X, Y, Z.
Sir,
Okay. Yes.
so in which situation we will use G40, sir? Cancellation of
Okay.
and nose
I will
radius.
I will tell that. Let's see, my job is present or we are fixed on the bed. Okay. Now we may do something on XZ plane or YZ plane or XZ plane. How the computer will understand? So previously we must provide that information by writing G18. Suppose we are doing something on XZ plane, we must write G18. And if we are writing something, we are doing something on YZ plane, I must give program G19. And if you are doing something on XY plane, this will be G17. Okay. So here we are doing something or we are machining on the XY plane. So we must specify this G17. That means the X, we are selecting a XY plane. Okay.
So in the next slide, can you explain the another figure
Okay.
given there?
I'll tell that. Let's see. We are going through the program now. See, G90, you know that this is for the absolute coordinate system. Then G0 is for the rapid movement. G40, G49, G80. What is that? G40 is your cancellation of your cutter radius compensation, and G49 is your, what is that? Compensation deactivating cutter length, and G80 is your cancellation of cant cycle. So this may be confusing. Let me clear that. See, here the tool that we are using, it will have certain diameter and length. If you remember your milling vertical milling machine, so it will be a end milling cutter. Okay. See, there may be two tools which will have different diameter and different length also. But so how the computer will understand that it has certain means it might have different dimensions like different diameter and different height. So we must give that information. Our computer should take that diameter and the height into account so that there will be no mistake. Okay.
So then, why are cancelling
Okay,
operation?
so let me tell. Previous to this machining, okay, the operator might have used some different program where they have defined a different cutter. The, he might define different cutter radius compensation, or he might have activated some cutter length compensation, all that thing. So prior to machine this part, we must cancel uh, if we have defined some other things, those values should be cancelled, and again we must define all these things. Because suppose that some other that operator have used a different tool for some other operation, and here we are selecting another tool, so for that this value will be a different value, means it will not be the same. So we must cancel any previous cutter radius compensation or this cutter length compensation or any cant cycle which has been used previously. We must cancel. This is a fresh program. Okay, so we must cancel any previous value already set to the machine. Okay, so then you have to go for G53. G53 is the machine coordinate system. So when we write G53 X0 Y0, that means the tool will go to the machine coordinate system. Okay, now T18 M06. Now T18 represents the tool number of 18. Okay, and M06 is the changing of the tool, M code for changing of the tool, and G0, G90, G56. By writing G50 means now we are selecting this watt coordinate, and also we are selecting G17 means this is the, we are selecting the XY plane for the machining. Okay, now on that we are going to X20, Y20. Okay, so now my tool will come here. Okay, now G43, H18, Z50. What is this? G43 means what is that? Activating cutter length compensation. So by writing this, I am activating, or the computer will see, or it will check what is the height of the tool number 18. H18 is not the dimension. H18 is the location where the height of the tool number 18 is kept. Okay, so it will just access this location and it will take the height value and do certain modifications in the program. Okay.
Sir, sir.
Yes.
So why we are using H18 and not H8? It's 8 number tool, no?
No.
Yes, sir.
See,
Tool have
see.
only maximum 8 tool.
Okay, that was for turning center. In turning center, there will be maximum 8 number of tool, that is called a turret. But in machining center, it is the this is called ATC, or automatic tool changer, or tool magazine, where more number tools are there. So there will be maybe 20 number of tools. Out of that, we are selecting only 18th. We are selecting the 18th number of tool. Okay. So
Okay.
H18 is the just location. Now M03 is 1500. Now my spindle is rotating at this RPM. Then G90.
Sir,
G90.
H18. Sir, H18 is the height of the tool.
It is not the height. It is just the location of the means the it represents the location of the tool 18 where the height value is kept. Okay, this means does not mean 18 mm. This is just the location where the height value, let's say 4.5 mm or something, or 10 mm. It is there. It will assess that value and it will do modification. Okay.
Sir, can we not use H18 instead of T18?
No, T18 means here the tool 18 we are selecting.
Yes, sir.
H18 is the location where the information regarding the T18 is kept. Okay.
Okay, sir. Got it, sir.
Now G90,
What is M03?
M03.
Yes, sir.
This is the spindle rotation clockwise. M03 you see cutter rotation counterclockwise. Okay. Now G42, D18. D18 is also the location in that computer where the diameter value of the 18 is there. Okay. So it will take that value. G42 is, what is that? G42 is cutter radius compensation right of side. Now while moving this tool, I want that my tool should shift to the right. So for that I have to write G42 for what amount or what is that value. It will assess that location D18, and from that it will take that value and it will just move the radius value. Okay. Now G01 G01 X20 Y20 feed.
Sir, D18, sir.
D18 is the location where the diameter value is kept, or it is stored. Okay, now G01 Z minus 2.5. Okay, means
Sir,
now,
sir.
Yes.
So in above line G01 X20 Y20. So
Yes.
I think it should be X110 and Y20, no?
No. It is means
Final.
it will if this is 00, this will be 2020, so it will come here. Okay. Because from this location it will come to this location, and from this location it will move like this. Okay.
But I think tool is going to the point 110,20.
No. First my tool is here. First it should come to this point. Then the tool should shift to the right of this side. Okay. Now it will move like this. We have not started from this point also. Okay. Now see, after reaching here, still my tool is not in touch with the machine. It is at a height. sorry, tool is not touching the workpiece. It is still at a height. Now, whenever I write G0 and Z minus 2.5, then only it will go and it will reach this value. Okay. Otherwise, it is at a height of Z10.
Okay, sir, got it, sir.
Okay. Now, after reaching this, it will go to X110 because the Y value is same. We are not repeating it. Then after reaching here, it will move to this location. This is a counterclockwise motion. So we are writing G03, X120 and Y30. Then the radius of curvature value R10. Now I think we can go like this. This is a linear path. This is a circular path and we know how to write this. So I think we can, there will be no doubt up to this point. Okay. This completes this profile machining. Okay. Now once it is over, what the next thing we have to do? We have to cut this profile also. Okay. This profile we have to cut. How we can do this? I will move to this point and I will just, I have to define these 2 points. After reaching here, I must machine up to this point and again after reaching this point, again I have to machine this point so that this cutting is possible. Okay. Now here you see, here after machining this path, I must cancel my cutter radius compensation. That's why I have written here G40. Okay, G40 means after doing this machining, I must cancel this cutter radius compensation so that I can write this coordinate and my tool will reach this point. Okay, so it will be G0 X70 Y50 this location, and then after reaching here, this there should be some drilling kind of operation, means not drilling, the tool will insert up to 2 mm to the Z minus 2.0 at a feed of 100. Okay, then after reaching here, it will move, it will machine up to this point in a counterclockwise manner, that is G03 X70 Y90, and the radius of curvature is, this is diameter is 40, means this is 20, and at a feed of 500. And similarly here after reaching here,
Feed means the speed of the workpiece feed.
okay, see the feed here is 100, but here it is 500 because when it moves, enters the job, this is similar to a drilling operation where the chip removal will be difficult. So we are advised to go with a slower feed, and once that is done, we can move in some higher value. So while going into the workpiece, it takes a lower feed, but when cutting this path, it will take, we may go for some higher feed, 500. Okay.
Sir,
Now, yes.
sir, M03 is the cutter rotation for counterclockwise, and G03 is also for cutter rotation counterclockwise.
It's not about the cutter. This is about the tool path. Tool path G03 means this is the counterclockwise tool path.
So
Okay.
basically tool is the cutter, na sir?
Yes. So
M03 is cutter rotation counterclockwise, and G03 is also.
okay. Okay, just let me complete the slide and you will have another video also to be watched, and after that we can discuss the queries. Okay.
Okay, sir.
So here after reaching this, we can machine like X70 Y50 R20. Now this also being machined. Now again, see after this we have to drill this at these 2 points. Again for that we have to go for a CANT cycle. So so for that actually we have to change the tool. So here initially we are using a 80th number of tool. Now we have to change the tool to T06. Okay, 6th number of tool, and again we have to define G56 means work coordinate system, then absolute coordinate system, and then what is the X100 and Y35. Okay, so it will come directly to this point, but it is still at a height of, what is this? It will be still at the at some height. Okay, now we are defining G43. Where is that G43? Okay, activating cutter length compensation because we are again using another tool. Okay, see, for this the diameter is, tool diameter is 6 mm, but here we want to drill a diameter of 10 mm. So you have to change the tool. Once the tool has to be changed, that means again we have to activate the cutter length compensation. Okay, so here we are using H06 Z50. Then again the spindle rotation is to be done. Then this is the G81 is for the CAD cycle for drilling. G99 is the return to R point. Okay, return to R point in CAD cycle, and this is the location where the drilling has to be performed, and up to what point? Z minus 2.5. R15 is not the radius, because in drilling there is no radius of curvature. This is some retract value. Suppose we have to enter, we have to drill up to 2.5 mm. So after drilling for some time, it will just move, the tool will move up so that the chips can come out and further machining can be facilitated. Okay, then the feed is defined to be F100. I think semicolon is mixed here. Okay, then in CAD cycle we have to define all the points where we have to do drilling. So this is the first point, X100 Y35, and the next point is X45 Y105 and Z minus 2.5, but as the Z is same, we are skipping this. Now the drilling is over. So G80 is cancellation of the CAD cycle, and G90 means the absolute coordinate system, and G53 is again we are going for the machine coordinate system, that is G0 Z0, and this ends your M05 is your spindle stop and M30 is your program end. Okay, so here another thing that see, in turning center there is one spindle, so at a time we can use only one job. Okay, but here in machining center means the tool is rotating. Okay, and there may be number of jobs that can be mounted on the same table. Okay, so for each job we can define a new coordinate system and fix it to some location, like work coordinate system G54, G56, like this. Okay, so what is the benefit of this? Suppose we are machining this part, and due to some reason we have an urgency to machine another part. Okay, so what we can do, we can stop machining for this and we can machine for another part by fixing or by defining another coordinate system. And once this part is over, again we can come to machine this part, because suppose there is 100 lines, we have done 50 lines over here and we switch it to this part. Now after this is over, again we can go to this coordinate system or this work coordinate system, and we can start from the 51st line. Okay, now let's see some of the advantages of CNC machine.
So only 6 different work coordinate system, or maybe more?
No, I think 6 work coordinate systems can be defined, or in some machines that may be varied. Okay, so advantages of CNC machine, as you see that there will be no involvement of that operator. He has just to on and off the program, means okay, so any less skilled people also they can operate the machine. Okay, and there will be some software. Okay, CNC machines can be updated by improving this software, and training of the CNC machines can be done through use of some virtual software. Okay, so then okay, so we do not require any human intervention. So we just need the human for only work loading and work unloading. Okay, other things the machine will take care of itself. And these machines can manufacture several components with required accuracy without any fatigue. Okay, and there will be savings in time that could be achieved with CNC machines, significant. So see, there will be some rapid actions. Okay, when there is no machining action takes place, the tool may move very rapidly, so it saves time, so it may increase the productivity. Now some of the disadvantages. So it is more expensive, definitely, that manually operated machines, and only so we don't need any skilled person. Okay, so it's increase in electrical maintenance, high initial investment, or high per hour operating cost than the traditional system, which make it expensive. Now instead of, suppose we have 10 conventional lathe, we want 10 workers. But if we have a CNC machining center or turning center, 10 CNC turning center, so there may be one operator and he can operate all the machines. Okay, so it may lead to some kind of unemployment. Okay, now
Sir,
yes,
the function of the lathe machine and the CNC machines are different or same? Means
so
all the functions of lathe machine can do this CNC machine?
yes, CNC means the turning center can do, but the thing is that it will be expensive. And as I showed that in the first slide, that the dimensions means the desired dimensions can be achieved with with less deviation. Okay, so there may be a doubt when to go for, if we have CNC lathe or turning center, why should we go for conventional lathe? Okay, that is a basic question. But see, in some cases we don't want this tight tolerance. Means there may be, means if the dimension, there is some deviation in dimension, suppose that is not a problem. So in that case, to reduce the cost of the machining, we may go for the conventional lathe. Otherwise, where suppose you have to manufacture some kind of spindle which will be mounted on a different part. If the spindle will have some deviation, it cannot be fixed that at that location. Okay, so in that case we cannot do it with the conventional lathe. We have to choose the, what is that, we have to choose the turning center. Okay, and in another way, suppose by in some cases we are dealing with some costly material also, whose cost will be in terms of some lakhs or some few thousands or few lakhs. Okay, so in that case, if my part will be rejected, so it will be a huge cost. Okay, huge demerit. So what we can do, in that case we have to select a CNC based your either turning center or machining center. Okay, we can't go for the your conventional lathe or milling. Okay, I think our this class is over, but we have to see a video on CNC mill. So now I am once that video is over, once this video is over, we can just take some queries.
He says, should I play the video?
Yes, sir. Yes, sir.
Then you may have to unshare the thing. Okay?
Yes. Yes, sir.
After you complete.
Yes, sir. I just unshared it.
So this one is the VMC, Vertical Machining Center. This machine, this is having 3 axes, X, Y, Z. Okay. X, the table will move towards the operator right hand side, that is X positive direction, and towards the left hand side of the operator, that is the X negative direction. This can move up to 600 millimeters in this machine. And Y, that is the transverse direction towards the operator. When the table is coming towards the operator, that is the Y positive direction. And when that is going towards the spindle, that means away from the operator, that is the Y negative direction. Okay. And the Z axis, when the tool that is coming towards the workpiece, that is the Z negative direction. And away from the job, that is the Z positive direction. So this Z axis can move up to 500 millimeter, and y-axis can move up to 450 millimeter. Okay. And there is a 4 servo motor is there. 3 servo motor for the all 3 axis movement and 1 for the rotation of the spindle. Now we'll see how to move the axis using different modes. Okay. Now we'll use jog mode. In jog mode, the mode selector. In jog mode, now we'll move the axis. Here the direction is there. Okay. And the feed selector. I'm opening the feed. X. Now I'm going to move X negative direction. X negative direction. X axis is selected. This is the axis selector. This is axis selector. This is mode selector. And this one is the feed selector. Okay. Now we're going to move X towards the X negative direction. I'm pressing this direction button. X negative direction. The axis is moving. X negative. Now X positive. That is the towards the left hand side of the operator. X positive. And now Y axis. Again I am selecting the Y axis using axis selector. Y axis. Y axis. Y positive. Sorry, Y negative direction we will select. Y negative is away from the operator. That is the towards the spindle. Y negative. This one is the Y negative direction. And Y positive towards the operator. Y positive. Now Z axis. Again we are selecting the Z axis using axis selector. Z axis is selected. And now we'll move the spindle towards the workpiece, towards the down. Z negative direction. This is moving. And Z positive direction. This time this is going up. Okay. Now we'll select the reference. This is the reference mode. Z axis. This time we'll open the rapid override. And positive direction is selected now. This is moving towards the Z axis, Z0. Y axis. Y0. And now X axis. This is X, Y, Z. This is the machine origin. And now we'll see how to write a very small program using MDI mode. There is a mode selector. We'll select MDI mode to write very small program. In this mode, you can write maximum 6 lines at a time. The program is the MDI program screen. MDI. These are the soft keys. Okay. In this case, you can write maximum 6 lines at a time. Now we want to rotate spindle using a program. Now I'm going to write the program. M03 S1000. And the block insert. The program is written. Now to execute this program, we'll press cycle start, this button. I'm pressing this. The spindle is rotating now clockwise. Okay. Now we'll see how to change the tool. Previously, we have seen in turning center, that is the CNC lathe machine, we have used the target. And here in this machine, we'll see the tool magazine and ATC. Okay. So now we'll write a program to change the tool. We'll call the tool. The code is M06 to call the tool, and we'll call tool number 9. This one is the tool number 3, and the tool number 9 is coming. The tool number 9 is changed. Okay, now we'll see the simulation of the program. Which one we are going to execute? This one is the program. Okay, already I call this program the screen and in the auto mode. Now here is the position of the tool. Tool is called from the home position to the job origin. Okay. And now the linear interpolation along the y-axis, it is cutting. Then this one is a circular interpolation counterclockwise. Along the y-axis, this is again linear interpolation. The next block, this is the circular interpolation clockwise. Along x-axis, linear interpolation. And at the same time, x and y will move transverse direction. Okay. Then along the y-axis, linear interpolation. Circular interpolation, again circular interpolation. Actually, what will happen practically, the cutting tool, it will be not moving. Cutting tool can move along z direction. Practically, the table that will moving along x and y axis. Now the program is selected and the mode is selected. We are going to execute the program.
So this is done. So if you want to have a real
Sir, you are
Sir,
not
you are
audible.
not audible, sir.
Audible,
Sir,
sir.
you are muted. Voice is not coming.
Sir, you are muted, sir.
just a minute, yes. Actually, seen it. Okay. So if you want to have a revisit of the video, it is already uploaded in MS Teams under files. Okay. The PPT, today's PPT also has been shared with you. So both the things, please go through it at your convenient time just to make the things even more clearer. Okay. But still, if you some doubt, some question, I think you can write in the chat box. We can answer from the chat box. Okay.
Sir, where we can get the theory for this?
Sir,
Sir,
if
you
you
are
have don't query, sir.
Audible.
sir, you are muted again.
What is happening?
Sir, your voice is not coming, sir.
Okay. Now it is coming.
Yes, sir,
Yes,
it is
sir.
coming.
Yes,
Yes,
sir.
sir.
Yes, sir, it's coming.
Okay. So if you want to see the reference about the reference, see last slide of the PPT is having the reference. Okay. So there you can go through the reference and get it. Okay. But I think simple doubt you can write in the chat box. From there our TAs will be try to answer to your question. Okay. Offline. First go through the things once again. You have your own thought process and go through the videos also. Okay. And there you will get it.
Excuse me, sir.
Rajas.
Sir, this semester is online, so